Alright, here's our problem. They call these systems of three linear equations, all right? Because there's three equations, there's straight lines, and what you got, if you look at it, you got three equations, you have three variables. So if you are given three variables, you must have three equations. They can't just give you two of these equations, expect you to find all three variables. If they give you three variables, x, y, and z, then they have to give you three equations. Now notice, x, y, and z is not in every single equation. Look, there's no z in this bottom equation, is there? But there's enough information to be able to plug some stuff in, do some substitution, maybe some elimination, right? Depends on what's going on in the problem in order to solve for x, y, and z. So that's what we're going to do. Now this is not one of those kind of problems where it takes 2 seconds and you're done. All right, it takes a little bit of work, but it's really not quite as bad as what it first seems. What we're going to do is you could do a couple different things here. Let's see what they do first. Yeah, I think that's what we're going to do. Yep. I was thinking about getting x by itself and then substituting x into one of those, but I think let's eliminate the z, because if we do this, watch. I mean, this is kind of rigged for you, don't you? Do you see that? I mean, they made it real easy because they got a minus z and a plus z. So if I take these two equations, these two top equations, add up everything in those equations, those z's will cancel out. So guess what I'm going to be left with then? Just x and y. So I'm going to have one equation with x and y, and look, this equation already has an x and a y in it. You see it? And so it should be pretty easy to solve. So this one's a little easier, I think, than the second one. So let's do that. Let's tell you what, I'm going to rewrite this. You may not need to do this on your own paper, but I'm going to just for teaching purposes, okay? So I write the first one, I write the second one, and then there we go. So what we're going to do is we're going to add these two columns together. So we're going to add all the x's, all the y's, all the z's, and all the regular numbers. You got that? You've done that before, haven't you? In Algebra 2? Probably Algebra 1. You probably did that stuff in Algebra 1 as well. So let's do that. What do we get for the x's? I get 5x, and I get 5y. Look what happens to the z's, though. This is elimination, right? They cancel each other out, or they add up to 0, and that equals what? 30? You could keep it like this, and that'd be fine. I see something right away. Almost hate to skip over it because it makes things a little bit easier. Look, there's a 5 in common with everything here, right? So basically I could do what? Divide everything by 5. It just makes things a little bit easier. You don't have to do that. You could take this equation, mess around with it, but I think it might be a little easier if I just divide everything by 5. So what am I going to get then? You can just do that in your head, can't you? X plus y equals 6. Good. So watch what I have. This is not my answer. I'm just putting it in a box. I do this a lot of times. So that's one equation with x and y in it. And check this out. I've got another equation with x and y in it. Do you see that? Yeah, that's why I put them in boxes, right? Because I'm going to take these two and do elimination just like I did with the first two. You could do a couple different things. There's all kinds of ways you could approach this at this point. Okay, I'm just gonna do elimination on this. You could, if you wanted to, you could get x by itself. So x equals 6 minus y. Take that, substitute it in for this x here, and then solve for y. You could do that. You could get this x by itself. So x equals 2y. Take that, substitute it in for this x, and then solve for y. You could do it that way. Or you could have solved for y and substituted in for the y and solved for x. I mean, there's all kinds of possibilities. I'm not going to go through every single possibility that there is. But what I'll do is this. Let's put them on top of each other like you said. This might be kind of easy. We'll see. Just depends what you like. Do you like elimination or do you like substitution better, or does it really matter? I don't know. So what do we have? What you could do, now a lot of teachers teach this. You could either add them together or subtract them from each other. Just for consistency's sake, I like to always say let's add them together. But if I add these together, nothing's going to cancel out, is there? All right? So what I'm going to do is I'm going to multiply everything on the bottom by a negative. Watch. So that'll make that negative, that'll make that negative, that'll make that negative. Now why did I do that? So that when I add up the columns, guess what's going to happen with the x? It's going to cancel each other out. Do you see that? So I always say add the columns together. Some teachers say subtract them. I always like to just be consistent, do it the same way every single time. I think it makes it a little easier. So just add up your columns. But what I had to do, what did I have to do? I had to make everything negative here. So I get one positive x and one negative x. So when I add them together, it adds up to 0. You see that? So watch. That cancels out. What do we get here? Negative 2y minus y. What's negative 2 minus 1? is negative 3y, equals 0 minus 6 is negative 6. Divide by negative 3, and we've got our first one. So y equals what? Positive 2. Let's circle that. So now, once you get 1, the rest are actually pretty easy. The rest is basically just substitution. So you get y, now you solve for x. I could take that and put it into any equation that has a x and a y in it. Or I should say that has a y in it, right? I don't know, let's just put it in this one right here. Is that all right? Doesn't make any difference at all. So this is going to be x plus what? 2 equals 6. So x equals 4. So now I have x and y. Now what do I have to solve for? Solve for z. So I could take any of these equations with z in it. I don't know, what do you think the easiest one is? Maybe this one? Yeah, that's got a minus z, and you could do that, that's fine. What I might think about using this one right here, just because the z is already positive, but it doesn't make any difference, does it? You could use either one and it will still work. I just like to use the easiest one, and I think this may be the easiest. I don't know, it depends on what your idea of easy is. So let's put this stuff in here. So it's 3 times x, so it's 3 times 4, plus, do you see what I'm doing? I'm just rewriting this, but I'm just replacing, I'm substituting in those values. Plus 3 times y, which is 2, plus z equals 16. Just show every step here. 12 plus 6 plus z equals 16. That's 18, right? So we can do that in our head, can't we? So z equals what? Negative 2. Now, I'll let you write the answers like this, that's fine, but the way they write it, and the way you should write it, as not an ordered pair, because there's 3 of them, so it's not an ordered pair. What do you think they call it? An ordered what? Instead of 2, a pair is 2. What do you think you would call it? 3. Yeah, well, it's kind of it. Okay, they call it a triple though, not triplet, but that's pretty close. It's an ordered triple, right? So it's not an ordered pair; it's an ordered triple. So there's actually 3 things in here. So which one do you think you put first? X, right, because it's an order. It's in a certain order. It goes in alphabetical order. X, Y, then Z. So X is 4, Y is 2, and Z is negative 2. So that right there, I got all these things circled and boxed and everything else. Let's do this in red so you see what our final answer is. Okay, that right there is your final answer. Okay, and that's how you want to write it. You want to write it as an ordered triple. That wasn't too hard, was it? They kind of rigged this, though, for us, don't you think? Yeah, because they made it kind of easy for us where they gave you a negative z and a positive z. Just to kind of get you going, all right? It's the first example. All right, let's see what the next one looks like and see if it's as easy. Somehow, I doubt it. But we'll see. It might be. All right, here's the second example. This is example 6.6 on top of 52. Let's see, now look, all 3 of these equations all have 3 variables. Remember the other one only had 2 in there, but they actually rigged this kind of easy, I think. Look, I got a plus z and a minus z. You see that? So let's do this. Let's take these 2 and combine these 2 together, and let's get rid of the z. And then guess what else we could do? Probably do the second and the third and get one equation. Do you see it? And that'll get rid of all our z's. And then we're just left with x and y, and then we can just do regular substitution like we learned in Algebra 1. Alright, so let's do these 2 together. I don't know, do you think you can add these in your head without writing it all out again? All we're doing is just adding these 2 columns together. Alright, so let's see, what are we going to get if we add those 2 together with the x's? 3x plus y, right, because it's 2y minus y, right, because it's a minus y. So it's plus y, and then that canceled out, right? So went to 0 equals what? 4. Good. Let's do the same thing here. Again, these are kind of rigged for us. Make it a little bit easier, right? But as time goes on, we're going to add the second and the third one. So add those together. So what do we get with the x's? Get 4x, and then you get, it's minus 3y, right? Because it's negative 1 minus 2. Negative 1 minus 2 is negative 3. And then what happened to the z's? Cancel out, the add up to 0, add up these, equals 1. Now, this equation right here is kind of like your normal looking equation, all right, with the 2 variables, right? That's what you learned in Algebra 1. You did a lot of this in Algebra 2 as well. So, what are we going to do? Now, this is not quite rigged as nice as what they've been doing so far, so we're going to have to do something. You could use a substitution if you wanted to. If you wanted to, you could get y by itself. Do you see that? Move the 3x over here. So y equals 4 minus 3x. Take 4 minus 3x and substitute it in for this y right here. Right? Does that look familiar to you? You could do that if you wanted to, and that would work. I'm not going to do it that way, though. I'm going to do it this way.
Could you count towards the negative 3 up?
That's what I'm going to do. Yep, I see a negative 3 here, and I see a positive 1 here. So if I multiplied this by a 3, the y's would cancel out, wouldn't they? I can't just multiply the y by a 3. I have to multiply everything by a 3, so both sides. So watch, I'm going to multiply this by a 3, and I'm going to multiply this side by a 3 as well. So let's see what we get. When I write that out, I get a 9x plus a 3y equals 12. So that's the top. The bottom I didn't change. That stays the same. Now it's kind of rigged for us, isn't it? We made it. Alright, we made it so that these will cancel out. That's why I multiplied everything by a 3 here, so that 3y cancels out with this minus 3y. So let's do that. Let's add up these columns. That adds up to 0. That's what? 13x equals 13. When I add up those, divide by 13, x is 1. Again, once you get that first variable, there's usually a little bit of work to do to get that first variable. Once you get the first one, the rest are pretty simple. It's basically just substitution. So I want to solve for y now, don't I? I can use any of these equations that I want to. Let's look at this equation right here. That would probably be pretty easy to solve for y, don't you think? So what I'm going to do is I'm going to put a 1 in for this x right here. You could have put it in for this x and solved for y here. That would have been fine. You couldn't have put it into any of these, though, because it has a z in it. You don't know what z is. But you can put it into anything that has an x and a y and then solve for y. I'm going to put it into this one that I put a box around. So it's 3 times 1 plus y equals 4. And that's just, you can do this in your head. I don't need to do that. So, right. So that's a 3. Subtract 3 from both sides, and y is equal to 1 as well. All right. Thank you very much. All right, so we got x and we got y. Now what do we have to solve for? Z. I can use any of these equations up here. It doesn't make any difference. Let's use the top one. But again, I could have used any of these three because I know x and y, and they all have x, y, and z in it, right? I think this might be the easiest one, so let's pick that one. So let's put the numbers in. I'll put a little arrow so you know where I'm putting this. All right, so what's x equal to? It's a 1 plus 2 times 1, which is 2, and then plus z equals 4. That's a 3, right? Subtract a 3 from both sides. Guess what z is? How about that? It's 1. So they're all 1, so the ordered triple should be pretty easy. What is it? 1, 1, 1. And that right there is your final answer. Okay? Well, that wasn't as hard as I thought it would be. I thought they were going to make that a lot harder. That was actually kind of easy. That always makes me a little leery, though, doesn't it? You're like, oh, yeah, what's next? This was easy, but they're going to make it real hard. I don't know. Maybe they might make it kind of easy at first. But a lot of the process that we went through, that's basically all you have to do for this. So now you should be able to do 11 and 12. All right, so tonight you're going to finish problem set 6. All right, hopefully you did some last night. Did anybody actually do any of that last night? You did it all except for 11 and 12? Okay, good. Yeah, I think I did say that yesterday, didn't I? I'll let you finish it up. What I'm going to do, so since you worked on a lot of it, I'm going to after I stop recording this, I'll read off the even answers, and since I got my answer book now, and then we'll see how you did, and if we'll have some time, and we'll maybe go over some questions you might have over it, okay? But then I'm not going to do a new lesson. I had planned to do a new lesson today. Thought I was going to finish 6 yesterday, but we'll just save that for tomorrow. All right, that's it.